This is the video for section 7.4. You're starting on page 221 in your student journal. We have a few new terms here to go over. So we're going to be solving these polynomials in this section. Um, and in the past couple of sections, we've been doing operations with them, adding, subtracting, multiplying, and now we're going to be solving them. So first thing you need to know is what factored form is. That's a polynomial written as a product of factors. So for example, x squared plus 2x, that's a binomial, a type of polynomial. I could write that as x times x plus 2. If I multiply that x in, I'd end up at x squared plus 2x. Similarly, we've started with something like x minus 3 times x plus 8 and multiplied that out and ended up with a trinomial like x squared plus 5x minus 24. In this section, we're going to be going from the polynomial to factored form rather than the other way around. If or the reason for doing that is something called the zero product property. We'll get to what that is in a minute, but the zero product property states that if the product of two numbers is zero, then at least one of the numbers has to be zero. So if you multiply two things together and the answer is zero, the only way to do that is if one of those two numbers or both are zero. When we solve these polynomials, we are getting solutions, or roots is the term for that. And sometimes we might see repeated roots where we get two or more of the same answer for solving a polynomial. So that is the vocab. Let's get into it. So we talked about zero product property a little bit. And if we have two numbers multiplied together and it equals 0, then that means that either the first one has to equal 0 or the second one has to equal 0. So that's a really important concept for solving polynomials because we do that by factoring. So we'll get a polynomial into factored form. Then all we're going to do is take the first factor and set it equal to 0 and the second factor and set it equal to 0. And then we'll solve each of those little mini equations. For us to factor, we need to work on finding the greatest common factor. That's the first factoring strategy that we'll work with. So finding the greatest common factor, first thing you want to do is probably just test to see, is that smaller number a factor of the larger number? But another way to check that is to write um, uh, our two numbers as their own factors. So I'm going to factor tree 4. I know 4 is 2 times 2. I know 20 is, say, 4 times 5. So when I look at these, well, I can take 4 a little bit further. 4 is 2 times 2. So if I'm thinking about finding the greatest common factor of these two numbers, now I want to know, what do they have in common. So 20 is 2 times 2 times 4, or 5, excuse me, and 4 is 2 times 2. So they both have 2 times 2 in common. So the greatest common factor of 4 and 20 is 4. 4 is the largest number that divides both 4 and 20 evenly. If we do the same thing with 18 and 6, I know 18 is 6 times 3. Well, 6 then is a factor of 6 and of 18, so the greatest common factor here between these two is 6. Um, Next, let's try 2 and 7. Well, can you factor tree 2? 2 is only 1 times 2. There's no other choices there. And 7 is 7 times 1. So do they have anything in common? Well, they both have a 1 in common. So the greatest common factor there is just 1. Let's try one more. How about um, 12 and 21? Now, I know 12 doesn't, or can't, I know 21 can't be divided by 12, but I do know that 12 is 3 times 4, and 4 is 2 times 2. So then let's try 21. 21 is 7 times 3. What do they have in common? They both have a factor of 3 in common, so the greatest common factor there is just 3. That'll come into play a little bit more later. Before we get into using the greatest common factor a little bit more, let's talk about solving. So on page 222, you have a bunch of polynomials written in factored form. You know it's in factored form because there's parentheses. So when you see parentheses, that means that you are in factored form. So what that zero product property was saying was that if I am in factored form, here's one factor, here's the other factor. If I have two factors multiplied together and they equal 0, that means that either the first factor equals 0 or the second factor equals 0. For number 3 here, that means that I would take 5p and set that equal to 0, and then also p minus 2 and set that equal to 0, because either this factor or this factor has to be 0 for the product of those two things to equal 0. So to solve this, I would divide both sides by 5. 0 divided by 5 is 0. To solve this one, I would add 2 to both sides, and p would have to equal 2. There are two answers to this polynomial because there are two different factors. Trying that again with number 5, I would have, here's my two factors, 2b minus 6 is one, and 3b plus 18 is the other. So again, it's in factored form. It equals 0. This means that either 2b minus 6 has to equal 0, or 3b plus 18 has to equal 0. So now all I have to do is just use linear equation solving to solve each one of these. So I'll add 6 to get rid of that minus 6. Then I would have 2b equals 6, and my last step would be divide both sides by 2. So I end up with b equals 3. To solve the other one, first thing I would do is subtract 18 from both sides. Then I would end up with 3b equals 18. Divide both sides by 3, and b is 18 divided by 3, which is 6. So there's my two solutions for that polynomial. So solving in factored form is only a part of it. We also have to work on solving polynomials before factoring them. That'll be in the second video, so make sure you tune in for that.